All right, here we have question number 19 in the January 2017 Common Core Algebra 1 Regents. This question is basically a definition question where we don't necessarily need to do any math. So let's take a look. The daily cost of production in a factory is calculated using CX, or C of X is equal to 200 plus 16X, where X is the number of complete products manufactured. Which set of numbers best defines the domain of C of X? The domain, let's recall that definition, is the set of all possible X values for a given function. Now, on the surface, we could certainly take a look at this and say, well, we can put in any value of X. There's no situation in which we'll end up with a 0 in a denominator because there's no denominator. We won't end up with a negative under a radical because there's no radical. But we have some context. X is the number of complete products manufactured. Well, if it's a number of complete products manufactured, we have to think, can we manufacture certain numbers of products? Well, could we manufacture negative products? Certainly not. So we could go ahead and get rid of integers. Integers are non-decimal values, but they include negative numbers. So it's ... -3, -2, -1, 0, 1, 2, 3, etc., etc., etc. And it goes on to infinity and negative infinity. Since we can't actually use negative numbers for complete products, well, we could use 0, right? No products might have been manufactured. We can't use negative numbers, so that doesn't help our domain for this particular function. Choice 2, positive real numbers. Well, it's definitely going to be positive. That's a good thing. Real numbers include anything that's not imaginary, and this course does not cover imaginary numbers, but real numbers include decimals, fractions, square roots of irrational numbers, etc., etc. So, some numbers that might fall under real numbers that wouldn't fall under integers would be like 2.5, 10/3. Pi is definitely a real number. Well, we can't manufacture pi products, or 10/3 products, or 2.5 products. It specifies that the number of complete products. So that's out as well. Choice 3, positive rational numbers. Rational numbers, by definition, are numbers that can be expressed as a fraction. That includes terminating decimals, any fraction. It also includes decimals that are repeating, meaning something like 0.33 repeating. We know that's 1/3. So obviously, again, we can't manufacture 1/3 of a complete product. So that's out as well. 4, whole numbers includes only positive, or at least non-negative, integers. So that would include 0, 1, 2, 3, ... and so on and so forth. So obviously, since we're doing complete products, whole numbers is going to be the best answer choice.